Okay. Okay, let's start today. First of all, I'm going to extend the workshops for a couple of days, the due date, because I want, as I mentioned, I think I sent you an announcement. You already know it, so it's going to be extended, and hence probably the reason that half of you are not here now, because you, anyways. So important stuff I want to just go through, and we'll see what we can do. Okay. So that's what's going to happen. Next week, you're going to have a quiz. A few days before the quiz, you're going to receive the ballpark of what the question is going to be. So I'm going to explain exactly what type of question you're going to receive and what are the concepts that you're going to get in your question. Okay? The question is completely closed book, and you know how to do your answering thing. You've done the agreement, and you know exactly how it works. Make sure that you do it exactly that way. And that's that. So now I'm going to go through some points that we did not discuss it in class. But from now on, remember, based on the weekly schedule that we have, you are responsible to study everything, even if I don't cover it, because there are so many things that I want to cover. Sometimes I just don't have time to go through everything. The rest remains on you. You have to go through it, study it, and the next day you're going to come in with a question. And then we'll continue after that. So, as usual, we're going to start by creating a project in the repository. But before I do anything, I will pull the repository. So I'm going to say create a new project. Empty project. Next, I'm going to select the repository, which is OOP244. And before doing anything, as usual, we pull. It's up to date. Now I'm going to go to Notes 3, and then we're going to select folder. It's going to be 04. September 19th. I'll create it. Okay. I'll create an empty file. prg.cpp. The reason that I keep doing it is that you need to learn to do it yourself. Okay, so there are two ways of actually doing the workshops that you're actually doing. One is like this, to create your own project yourself and then get the files. The other way, I'll show it to you. So I'm going to kind of demonstrate how the workshop and projects are being done. So this is the first way. Well, you start, and then you're going to start having the files. So if this was your workshop 1 that I wanted to work on, then I would, after this, I would actually go and open up the directory. So now this is the directory of the project I created. It should have been called WS01, exactly like what I've done over there. And then you, let me open another one. So then you go to the repository of the workshops. You pull it, making sure everything is good, because I may make some changes over there. You need to be aware of it. So I'm pulling it, and the pull comes in as success. So it's updated. Now I can go in here in workshop 1, see exactly what the files are. I'm going to get the files that I need. Copy it. And then I pasted the project that I have in my repository. as I mentioned, never, ever work in my repository in OOP workshops. That's mine. It's read-only. You're not supposed to work in there. You're supposed to work in your own repository. So assuming that this is the repository that I'm added as a collaborator, you add it into this one. Now that it's added over here, you can actually add the file. So I can right-click on the project, and I can go add existing item, and I can select all the stuff that I have in here. 1, 2, 3, 4. These are the things that I added, and I can, the PRG is already added. And I can click on add. Now everything's going to be added. CPP files are in CPP. I'll move these ones in resource files because they are resources. And now I start coding, adding header files, whatever that is needed. So that's number one. If you want to create stuff scratch on your own. But if you don't want to do this, there is another way of doing it. So I'm going to remove all these because I don't want them for today. And I can actually, I should have deleted it, but I just removed it. I'm going to delete them too because I don't need them. Okay. Another way of doing it is that you go to your repository wherever you are supposed to be. Let's say I want to have my workshops here. So let's say in your repository you have a workshops directory. If that's the case, all you need to do is to simply go to the OOP workshops after pulling. Just copy the directory of workshops from OOP workshops into your own. There we go. So workshop 1 is over there. README file lab, everything's over there. All you need to do is to open lab, double click on either lab SLN or lab BCXproj. And that's going to open Visual Studio for you with everything that you need. There you go. Everything already ready in the project, and you start working in there. Okay? So this is how it's done. And I did draw the diagram of how to work on your repositories, right? Number one, you clone, then pull and push and stuff, right? We've did that. Oh, we've done that. Okay, so so now if you look at that repository, you'll see everything's there. Obviously, the header files are not there. You have to create them, but whatever you need, they're all here. You can actually start working with them, which I don't want it, so I'm going to wipe it out. I'm going to go back to notes, and I'm just going to delete that. And be done. Okay, so let's go back to our work for today. So I'm bringing up notes, and I'm going to go through the notes, see what we missed, and I'm going to cover all those things today and maybe more, okay? So the reason that we fell behind on covering everything is that I had to go through all the pointers and stuff to be able to make sure that your bases are strong when you're starting with pointers. Now that we've done all these things, we can actually I'm going to go through the first 3 things here. What is missing, fill in the blanks. You're done. Give you 2 extra days to finish up your workshop, and you're done. And many of you are already finished. So, but anyways, so there is no restriction for workshop 1 to be submitted from the lab. I'm going to remove that restriction so you can do it later on. 2 days extra or something. But workshop 2 is on time. It's going to be next week, so you have to work on that one too. Remember that. Okay, so we talked about programming languages. We said that C is a subset of C++. Everything that you have done in C, you can actually do it in C. That little thingy that it has over here is very small. Like I don't remember anything that I've done in C that I couldn't do in C++, so I don't even know what is that little thing that is not inside C++. Everything's there, so that was purely done. We talked about C++. We talked about type safety, segmentation, fault, core dump. Whenever you see something like this, it means you have dealt with a pointer that its address is not set, or it is not a right one. So whenever the address that you're dealing with doesn't belong to you, that's segmentation fault, core dump. So essentially, what is segmentation fault? It means you are trying to read from the memory that doesn't read or write into, or from the memory that doesn't belong to you. And it doesn't know that you're a rookie. It thinks that your program misbehaved. Therefore, what happens, it actually takes a snapshot of the memory and saves the entire memory into a file on your account. So you can open up and see what was the memory configuration and debug it. Make sure you delete that. It occupies lots of space in your account, okay? Make sure you wipe those out. So whenever you see this message, the core dump, essentially, it means it dumps the core memory in there. We did not talk about namespaces. So let's see what namespaces are. When you work in a big department or big programming, a big company, there are many different abstractions to look at the same thing. Do you remember what was abstraction when we say abstract? The person with the microphone will answer. Do you remember what abstraction was?
Abstraction is generalizing things and focusing on just one particular module.
Fantastic. No, one particular aspect of this problem and ignoring the rest. That's what we call abstraction. So let's say you are in Seneca doing programming, and I have to answer this. My apologies. My apologies. Okay, no, it's good. I thought it was the medical alert from the device, but it wasn't. My mistake. Anyways, so what I want to say, yeah. So let's say you are programming in Seneca and you want to create a structure or a class for a student. If you want to do that, depending on which department you are, the way you are looking at the student is different. If you are in an education department, then a student is name and GPA and the number of courses taken and things like that. But if you are in finance department, then if they took loan, or what is the balance of your one card and things like that is important for it. So finance, education, two different things. So because each programmer in its own department creates its own class, both classes are called student. So if you compile the code, compiler is going to give you an error, tell you, hey, you have two classes with the same name. That's not going to work out. They fix this problem by creating something called namespaces. So let's say I am in the education department and programming. In education, they say, hey, everybody in education must enclose their code in edu namespace. So all the people programming in the education problem, they program in namespace edu. So if they want to create a student, this is what they're going to do. So if this is the student.h header file for the student, okay, the very first thing they are going to do is to create a safeguard for the student. The namespace is edu, so what they're going to do, they're going to write, if not define, edu student underline h. So the first one is the namespace in which you're programming. The second one is the name of the header file. The third one is .h, underline h. So you write that. And usually, not to make mistake, you need to copy and paste it again, but this time change the second one to define. And then at the end, you're going to write end if. So this is the beginning of student.h, and that's the end of student.h. Okay? So this guarantees that if you include student header file twice, the compiler will only include it once. Remember, anything that starts with a hashtag is you talking to the compiler. It's not C language. It's not C++. You're actually telling to the compiler what to do. So you're telling to the compiler, if edu student underline is not defined, continue compilation. So it compiles the next line. The next line says what? Define that token. And it continues all the compilation and keeps going through. Now, if you include this twice by mistake, what happens? The compiler wants to compile the second file, for the second time. It comes over here. If not defined, but it's defined. So it ignores the whole thing. That guarantees that it's only compiles once. If you understood what I said, good. If not, blindly follow this rule. You enclose your header files, all of them, in such thing. It starts with namespace, name of the header file, and h at the end. Then you enclose everything in the namespace you are programming. So namespace, edu. In your case, all your code is written in a namespace called Seneca, because you're all Seneca students. So all your code, anything you write, will be enclosed in namespace Seneca. So that's that one. That's your header file. So in header file now, I want to create my student thingy. Now I can create over here struct student, and this student of mine has I don't know, character name 50 and so it's education. Let's say I'm going to say float GPA. Okay, something like that, and whatever. And for the CPP file for the student, so student.cpp, what you do first, you include student.h. So include student.h. Obviously, it's going to give me an include. Okay, it's giving me an error because this file doesn't actually exist. Okay, I'm just giving you an example. So then in your student.h, what you do, you simply write namespace edu, and you write whatever is needed. So in here, I'm going to say, I don't know, void register student pointer str. So let's say this function register is supposed to register the student. Okay. Oh shoot, register is a keyword. So I'm going to call it reg. Okay. And then in your CPP, what you do, you implement everything that is supposed to be done. So void reg student pointer str, and in here is going to be whatever. Okay. And this is end of student.cpp. Okay? Are we okay with this? Simple enough. Everything's good. So the files are created and we are done. Now, if this was, say, the Department of Finance wants to actually create a student. So what it does, it creates a header file. In here it's called OSAP, let's say. It's still called OSAP, right? Ontario Assistance, right? We do have something like that. Student loan is called OSAP or not? No? It is? Okay. So OSAP.h, it creates something like this. Now this is in finance. What they do, they create what should we call it? If not define. Now in here I'm going to write FIN underline OSAP underline H, and then I'm going to add the define. And same process happens over here. Namespace, finance. And in here you have a class called student. There is no conflict between the two because the namespaces are different. One is finance, one is in that one. So this one may have a name too, character pointer, character name 50, whatever. The other one, did I put a pointer by mistake? Yeah. Okay. And this one has, I don't know, double balance or whatever. Different types of abstraction for the student, and obviously in OSAP.cpp, and probably there's another class over here called class, let's call it loan, and in that one we have whatever, okay? So in OSAP.cpp, the very first thing that we do, you include OSAP.h, and you write namespace, fin, and you write whatever is supposed to be done for that. Like this, all the students are separate and there is no problem with them. So in your main, I'm going to comment this. Let me see if it's going to give me an error, but anyways. So let's say in my main, I'm going to call this a student, a structure, sorry. Struct. I went ahead of myself, struct, okay? So in my main, if I want to create a student for finance, then what I have to do, I have to say finance, student, FN. That's a finance student. If I want to create an education student, I'm going to call edu student ES. That's for it. So this one is a student from finance's point of view. This one is a student from education's point of view. Okay? Now sometimes you want to do, so in here, let's say I want to create a structure for the loan too. So I have to say finance, loan, and I'm going to put L. So most of my work is with finance. If that's the case, I don't want to keep typing finance, 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 finance. If that's the case, what you can do, you can just remove those and instead write using namespace finance. And done. So if you do that, then for this, you do not need to write FIN. For this, you do not need to write FIN, which means if you do not mention what, it's going to use FIN instead. Okay? Now, when they added these namespaces to C++ long time ago, again in a galaxy far, far away, what happened is that they said, okay, what do we do with all the stuff that comes with the language? They said, we're going to create a namespace called STD, standing for standard, and everything that belongs to the language will go to the namespace STD. And that's why Anytime I say include IO stream, I say using namespace STD because I want to use C out, I want to use C in, I want to use all the things that are in standard namespace. And that's where STD is coming from. Are we good? That's it. But remember, if you do not, if in here I say using namespace edu, now I'm going to get an error for the first student, not for loan. So the ones that have conflict, I can still fix it. So as you see, because both FIN and EDU have student in it, I have to qualify the student, but loan I don't need to, because loan is only in that one. So if you use two namespaces with the exact same name of an entity, you can still use it if you qualify it. We good?
So what does include STDIO do?
That has nothing. I'm talking about namespace. Include, we talk about it. STDIO is a different, and the namespace is a different thing. Include, we talk about it. Okay.
Yeah, I know what it does. It adds.
Yeah, wait. Does namespace start with a hashtag?
No.
No. This is a C++ statement. Hashtag is a C++ compiler statement. They have nothing to do with each other. Anything that starts with hashtag has no relation with this. And include is literally a copy and paste. I did give you an example on it. Did you? Did I?
In the last class,
Boo Boo and Biba thing like that. I put some.
You're including a standard C library, but how do you refer to, it's like STDIO and STD. How do you refer to the library exactly?
Like you've done in C. What's the?
I know, but it's not that, IO stream is different than,
Oh, do you mean lack of .h? Is that what you're talking about?
no, the one that lets you use C in and C out.
Include is include. Same thing from C and C++. The only difference is that C++ doesn't have a .h at the end. The concept is identical. There is absolutely no difference. Include in C++ and include in C, they are identical things. They are both copy and paste. IO stream is a header file in the library. It gets copied and pasted into the thing. It just doesn't have a .h at the end. That's it.
Okay, so it's include IO stream.
Include IO stream brings input output stream, and that's it.
Okay.
Okay, so, but yeah, that's a different story. We're not talking about that now, okay? Anything that you used in C language with a .h, drop the .h, add a C at the beginning. If you want to use standard library, instead of writing stdlib.h, you drop the .h and you call it cstdlib. That's it. So any header file that comes from C, you drop the .h at the end, you add a C at the beginning. It is exactly the same thing. Are we good? They are identical, exactly the same thing. And I'm lying here. There are minor differences, but it's way above your pay grade. So when I say like that, believe it, the outcome is identical. So when you do an include, it means it literally copies and pastes the content of that header file where the include statement is and removes the include. That's what it does, okay? That's namespaces, and we're done with it. So okay. C in, C out, C in extracts from keyboard, C out writes into keyboard. So essentially, if I'm going to say over here include IO stream using namespace std. Yes. Of course. Thank you. Better? All right. So enter a number. cin num, and the numbers here, I'm going to write int num. All right, see out. You entered num. Okay.
What happens if you've got more than one namespace?
So, pardon me?
What happens if you're using IO stream and also your own namespace? Because you have defined functions in that namespace.
I didn't get the question.
What happens if you are using IO stream for the standard input-output functions, but you're also using another namespace?
There's no difference. Just you add another namespace.
Okay.
You can add any namespace that you want. But you can use many namespaces, especially when, so remember, main, okay, main never implements a namespace. You don't enclose main in namespace Seneca. Main will use namespace Seneca. So all your code will implement the namespace. In main, you use namespace Seneca. Remember that, okay? Remember that. So in main, you will see at the top, that is usually written by me to test your outcome. You will see at the top it says using namespace std, using namespace Seneca. So it includes your names. Okay, it brings the scope of your names in. That's all. Okay, so again, this C in and C out, they are polymorphic. The insertion, this is called insertion operator. This is called extraction operator. They are, what shall we call it? They are polymorphic, which means you don't need to mention what is the type. So in here I can have double denum. So in here I can say double, and I can say enter an int and a double. Space separated. Okay, now I can actually do this. Now I can write this denum. You entered this and that. Are we okay? All right. So I'm going to run this. So you see how it works. So in here I'm kind of 1, 2, 3, and 1, 2, 3, 4, 5, point, something like that. And I hit enter, and this is what you see. Cout has a mind of its own. It formats the thing the way it likes. You can change it later on. So this not always comes out. It always looks at the number and says, what is the best way to show this number? I'll show it to you. So as you are seeing right now, if I actually run this, one, 2, 3, and I'm going to go 1.2, 3, 4, 5, 6, 7, 8. As you see now, the number of decimals are different. Now go ahead.
Go over how to, it's equivalent to the scanf command, but the notes go over how to basically.
It has nothing to do with scanf.
Well, no, it's the same command in C++. Right, so there's num and denum for double, and and scanf has its own syntax. Do the notes go over the syntax for cout and cin?
Of course it does.
Yeah.
Okay. Okay. But baby steps. For now, this is it. I'm telling cin and cout, first of all, they are not commands. They're objects. We don't have commands here. Cout is an object that impersonates console. Cin is an object that impersonates input console. You extract something with from cin. Whatever is your input console is going to provide that information. You have to think of it that way. These are objects doing things. It's not a command, and we're going to learn everything about them by the end of the semester. But baby steps. For example, for now, if you don't enter it properly like that, some garbage is going to come in. You don't know how to make it foolproof. We'll talk about it when the time comes. Okay? Cin.
It all
C out, C in, C out, intro. Okay? Play with it and you'll see what I mean.
Yes.
Okay, I want to see what else in here that is missing. This is good. Object terminology, we talked about it in extent. You know exactly what classes are, all the good stuff, encapsulation, polymorphism, summary, modular programming. Modular programming, I showed you the compiler with modules running separately, right? So each module will have its own header file and its own CPP file. The header file of a module holds all the declaration of what that module is supposed to provide, and the module that is a CPP file holds the definition of those declarations. Therefore, if any other module wants to use the capabilities of this module, includes the header file, therefore it knows how it is supposed to be used. At link time, the compiler will go into actually investigate and see if the declarations that you included matches the definitions that you have in the modules. Each module in our the workshops, usually 90% of the time, each class has its own module. Let's put it that way. So if I tell you create a class called the student, create a class called transcript, it means you have student.h, student.cpp, transcript.h, transcript.cpp. You have two modules. And then you have a main that uses all these. How do I name these things? Because it's Seneca, you're going to create a safe empty state for transcript. It's going to be, if not define Seneca, underline transcript, underline H, all capital, and then define and end if at the end, and namespace Seneca, you put everything in there. You should, like, if somebody wakes you up at 3 o'clock, hey, wake up, write a header file. You should quickly go, safeguard, namespace, now let me do. What am I supposed to write? An empty header file is a header file with safeguards and a namespace. Got it?
Yes.
Okay, yes, go ahead.
What is a class? What's that in C? There's another word for it.
Wait, time comes. We're going to come to it. So these are all modules. We know exactly what they are. So we're going to talk about classes and everything. We're going to go through it, but the very first thing that we needed to know was understanding what overloading and everything is. So we talked about overload. I showed you the bar thingy, and you know that you can create the same function name with different argument lists that shows actually what the functions are. So essentially, a compiler will find out which function to call using the argument list under it. So we are good with that. Anything that I mention over here, for heaven's sake, if you don't understand it, ask a question. Okay? Stop me and let me explain. So that's that. We have that. Fundamental types, Boolean characters, int, short, long, 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 and float, double, long, double. We said that these integers, the biggest number that they can go is 2 to the power of the number of bits they have. So a character, 2 to the power 8, that's the biggest unsigned number that it can be, divided by 2, that's going to be minus positive, okay? Same thing for short. Short has 16 bits. So 2 to the power 16, that's the biggest number, unsigned number that it can get, divided by 2, minimum, maximum. Int, 32. Long, 32. Long, long, I don't know. Depending on the platform, could be 8 bytes or 4 bytes. You can always check it out, but that's what it is. Floating point numbers, we said floating point numbers only deal with the number of digits. If the number of digits in a floating point goes more than 7, forgetting about leading or trailing zeros, it goes more than that, it loses its precision. And doubles, if it's 15, forgetting about leading and trailing, if it goes more than that, it loses its precision. Long double, we don't even know. Let me just actually. So in CLang, Linux and GCC, so number of significant digits for long double. In CLang, Linux and GCC is around 18, 19 numbers. And on Windows, 15, 16. So it's something like, almost like a double, okay? Just letting you know. Boolean, we said it's exactly like an integer. The only difference is that any non-zero value you put in it, it's going to turn it to a 1, right? If it's 0, 0. That's what Boolean is. It's better to return a Boolean if you're returning truth or falsehood. Please do so. But that doesn't mean that 3.59 is not true. Remember that. When you check a condition, not 0 is true, not only 1. Okay? Compound type, as we talked about it, they're structures that hold values. And when you create a compound type in C++, it becomes a type. You don't need to repeat the structure. We talked about declarations and definition. Declaration identifies what is to come. Definition tells you what the thing that is coming, what does it do, and what does it stand for. If you have the definition before the code that is using it, the definition itself becomes the declaration. If you have a function before another function, you don't need to have a prototype for it. Okay? Soon we're going to learn how to create prototypes like we do for functions, for variables. The variables that you create in a module, they are essentially 2 seconds. The variables you create in a file, they have a file scope, not global. There's a trick to make it global, which is a specific declaration we have to add to it. If we don't, then we don't. Yes, what's up?
So declaration is not prototype?
Yes, it is.
Oh.
Declaration is prototype. Definition is the function body. Okay? But soon you will see that declaration and sometimes a definition can be declaration, but a declaration cannot be definition. If you have a function before main, you don't need to create a prototype for it, because the definition of function declares it too. But if you have the body at the bottom, you have to have a declaration at the top. Otherwise, main doesn't recognize it. It's as simple as that.
I think we learned that in C2.
Oh yeah, it's in C2, yeah. In C++, we're going to go with, okay, these are, forward declaration. So for, okay, let's do this. I'm gonna create something like this. This is something that is way too early to talk about it, but it's here. I'm gonna tell you anyway. Okay, I'm gonna give you a. Do you know what's the chicken and the egg problem?
Which one came first?
Yeah, we fixed that one with forward declaration. I'll tell you what's going on. So, say I have over here a structure for a transcript, okay? And we have a structure for a student, okay? So a transcript belongs to a student, right? Correct? But a student needs to know where its transcript is. So inside that student, I want to create a pointer to transcript. So I'm going to say, I'm not creating it. Transcript pointer T. So essentially, I want the student to know where its transcript is. So I want the student owner to be able to know in which transcript it exists. If I do this, I have a problem. Because if I put the student with transcript, transcript is coming after. So it won't be able to access it. If I bring the transcript up, the student's going to come. So chicken and the egg, right? The difference is that transcript has a student instance, but student has only a pointer. So student is not creating a transcript, it's just referring to one. But the transcript is actually creating a student. So you always put the one that creates it second, the one that refers to first. Now you can create a prototype at the top. You can say over here, struct transcript, exactly like a prototype of a function. So you are saying, hey, compiler, don't worry. There is a structure coming called transcript. Create a pointer for it for now. You'll find out what it is later. I could not do that the other way because construct transcript, if I have this, then it's an impossibility. It's an impossible thing because it tells you you are not giving enough information how to create one. I don't know what a transcript has just by saying it's a transcript. A function prototype gives all the detail you need about a function. It tells you what is the name of the function, what it returns, what are the arguments, everything. That's why you don't need the definition to create a code for its function call. But to create a class, just the name of the class is not enough. You need to know exactly what it has. That's why it cannot be, it cannot create it. It should be either a reference to it or a pointer to it. Hence, forward declaration. Got it? Okay. Okay.
Sorry. Just so I can research on it a little bit more. What was that called?
Forward declaration? Yep. It's a good idea to actually read the notes too, you know? It's all in there. So please go through the notes. Okay. Okay. So, system header files, okay? This is how you include them, with less than and greater than after, IO stream and stuff. I have no idea what the second one even means. Other system header files? Don't know what it means. Forget about the second one, okay? Your own header files, custom. So essentially, system header files, custom header files. Done. Middle one, garbage. We don't need to know it, okay? Scope, we talked about global scope, file scope, function scope. I had all the examples. Any problems with it? Any questions? Suggestions? Objections? Iterations, okay. I don't think I need to go through for loops, do I? Okay. Shadowing, we mentioned about scope and shadowing, and I said whenever you have a variable outside of it, in an inner scope, if you recreate it, it shadows that one. It was through scopes. So with scopes, shadowing happens in all cases, okay? So if you have at any moment any inner scope with a variable carrying the same name of the outer scope, it will shadow it. So if I had an int out here too, int I, a file scope variable, the main would have shadowed that one, and then let me actually put it over here. So this thing that, so what I mean is that if I had this, main cannot have access to I because this I is shadowing it. 4 cannot have access to neither I because it's shadowing both of them. Got it? Yeah. Okay. Simple. That's shadowing, not scope.
So if something inside a loop has, it means it can't get access.
No, yeah, so you cannot access anything out there. So what you do over here is that, yeah, so this I dies at line 12, this I dies at line 14, this I dies when the program ends. Okay? The scope of this I is this file, nowhere else. The scope of this I at 7 is the main. The scope of I at line 10 is the for loops body. Okay? By the way, J has the same scope. At the end of 4, it dies. If you go back 10 years, there was a conflict. Some compilers, so the reason I'm telling you is that you may end up sometimes, you have to use an old compiler, just letting you know. It happens all the time. You go, you are fixing an ATM machine in Costa Rica that is written with C++, C++99, okay?
Yeah.
Something like that. It happens all the time. So some compilers, like old compilers, when you put integer j, they would have been the scope would have been after line 9 to the end, okay? But now all compilers end the life of the variable to the end of the loop, okay? So if you ever see there's an error, then all you need to do is to put that thing outside, and you know what I mean. Yeah.
Yeah. Makes sense.
2 people left. Anybody wants a break?
Sure.
Okay, break, 5 minutes, come back.
So you talk about the forward declaration. You must have a pointer in here to refer to this.
Yes, yes, yes,
Okay.
yes, yes.
Okay, thank you.
Or a reference. They would have both,
Or the at sign?
yeah, answer.
Oh,
But that's more tricky.
okay, but use pointer.
We'll find out later on, but for now, just pointer.
Just
No extra stuff.
I
No,
might
they're
be
just
doing
stuff.
pointers a bit, sorry, namespaces a bit different way. Is that all right?
One more time?
I might be doing namespaces a bit differently. Is that all right?
Well, you want to put namespace at the beginning of every single thing? You crazy?
That's
Put it
usually
in.
what I do. Okay.
Because it generated it for you automatically, that's what.
No,
You did it yourself? Okay, you're nuts. Put the thing at the top while you're putting everything. You can, but hey, seriously?
Okay.
Okay. I don't know, I wouldn't do that.
What about STD?
Hmm?
What about STD?
E-
Should I
Yeah, of course.
or-
You're one of those guys who like to type much, no? Yeah, sure, but yeah, it's not a mistake.
Okay, yeah.
This is fantastic, this is okay. There's no problem with it, but I wouldn't do it.
Okay. And what about STD? Because I usually don't.
Same
like
thing,
to use
same thing,
STD, but-
same thing.
Okay,
Oh,
and if you
terminal.
do,
Hmm?
Are you terminal? Are you saying?
No, he's talking about, he doesn't like to write using namespace at the top.
Oh.
He keeps
Yeah,
qualifying every single thing.
I wanted to know.
Fill me now. Okay, okay.
I wanted to know if
Over here and resume recording over here. Okay, so about namespaces and using namespace. Now I want your attention. This is extremely important. Extremely important. You are never allowed to use the statement using inside the header file. You are never allowed to use the statement using inside a header file. So in a header file, if you want to use something from standard input, standard namespace, you have to qualify it. Like if you are doing, later on you'll see, if you're doing, for example, IO stream, you have to say STD scope resolution something, okay? You have to qualify it. In header files, we are not allowed to use using. Why? Because if you do that, anybody including that header file without knowing will start using a namespace, and that's disaster. We are not supposed to do that. That's called hidden logic. You must never, ever have the statement using in a header file. Just remember that. Okay. So function overloading, we talked about it. Default parameters, you know what they are. References, we went through it. Pointer to functions, yada, yada, yada. And now we're going to talk about something very interesting. That is, When you create a variable, array, anything just like that, well, we call it a statically allocated memory, which means whatever you create is inside your executable. Therefore, you don't need to worry about it. You create an array of 5 integers, your executable runs, the 5 integers come to the memory, and when your program ends, your executable goes, and everything inside the executable vanishes. Got it? Because of this fact, you can never have a variable size for this array. It must be always 5, because at compile time, it decides what the size is and creates it in the executable. Therefore, when the compiler is running, this is 5, and you're stuck with it. Got it? Now we have a new way of doing this. We can actually create, kind of procrastinate in creating body of an array or a variable after execution. How do we do that? Like this. Instead of writing integer A5, we know that an array is essentially a bunch of variables pointed by a pointer, right? So instead of doing that, we can do this. We can say integer pointer A is equal to new int 5. This is a C++ statement. It's not at runtime. It's not at compile time. It is at runtime. So your executable will only have a pointer in it. And when it is being executed, it will actually allocate memory for it. The only catch for it is that because you created it, you must delete it. If you do not delete it, you will have what we call a memory leak. So because you are creating the memory, you must delete it at the end. Now, how? And how all these things happen? So what you do, you create a pointer to a type you need, whatever it is. Type that, whatever type. Integer, double, employee, student, car, transcript, character, whatever you want. You create a pointer, and you always set it to null PTR. This should be like religion for you. A pointer that is not used is always null. Remember that. You never leave any pointer uninitialized. Because if you don't initialize it, it's a value, right? When it's a value, you don't know if it's really address of something in memory or it's garbage. That's why an unused pointer must be null. Got it? Obsessively. So, when you do that, if you actually try to use it that way, you will immediately get a null pointer assignment. If right after you do that, you say PTR 5, then what the heck? It's null. You're saying 5th element after nothing. It's going to immediately crash your program saying null pointer assignment. Hey, what are you doing? You have a null pointer assignment. So that's going to go bad. The good way of doing it is 2 ways. Like if you are doing it as an, yes?
Is there a difference between assigning the variable to 0 and null PTR?
Yes. Make it null PTR, not 0. Or put empty curly bracket in front of it, universal one. So either you say integer pointer A equals to null PTR, or you say integer pointer A, open curly bracket, close curly bracket, semicolon. That's the universal way of defaulting something. You can, for now, do null PTR. Null PTR essentially means null pointer. It's a reserved type, reserved constant value in C. Okay?
Say they never use 0.
Pardon me?
When you say they never use 0.
Don't use 0, no, because it has to cast it. Okay? So zeros are different, people. A 0 for a pointer, and a 0 for an integer, and a 0 for a character, and a 0 for a double. They are different zeros. So let's not. Yes.
So for count characters from, no, count numbers from 1 to 10. I have count initially to null pointer first. And
No, not a counter. Only pointers.
oh,
Only pointers set to null PTR, not an integer for counter. That's a 0. Okay, only pointers will be set to null PTR will not used. Okay, now the correct syntax for it is to write data PTR is equal to new whatever the type is, and then you put the size. PTR is equal to new int 5. It means 5 integers. In this case, I'm saying 7 of them. And then you have to stay within the range. So if you actually stay within the range, you're fine. If you go out of the range, that's segmentation fault. For all those people who deal with characters, when you have a character string, if you want 10, you must have 11 because it goes with null pointer. Even one character out of your memory and you get segmentation fault. That's the most common thing. To dynamically allocate a name, they get the length of the name. It's 10. They allocate 10 bytes. They copy and it crashes. Because 10 characters need 11 characters. So remember, for C strings, you always have to add 1. Only for C strings. If I see you add 1 for a regular array, I'll be mad. Like, I want 10 integers, I put 11. That's not the case. 10 integers is 10 integers. But only for C strings, you need a null termination character extra. We good? All right? All right.
Real big question, I think everybody's gonna do. So you basically have a variable that figures out how long something is, and then you use the new statement, and you put the variable in it, and it assigns it dynamically to the heap.
We'll come to it soon. I'll show you exactly how it is. But be aware that, as our friend said over here, because you are allocating the memory, it's always wise to have a variable to know what is the size and update it when you change it. We'll come to it soon. Okay? So this is the syntax for it.
Sorry. Why do we have data leakage? Am I getting error?
Why we have data linkage?
Leakage, like you said.
Leakage.
If we don't.
So because it doesn't, because you created it, when your program ends, it doesn't get deallocated. It's like you are renting a room, okay, and you don't tell that I'm out. The hotel thinks that you need the room. You're out. Nobody's there, but room is there. The hotel has one less room to rent out. If people don't do that, soon the hotel will have all his rooms occupied with no one in the room. And that's when the hotel crashes.
In a static way, so after compiling is done, it automatically just gets rid of it.
You just ruined my day. It has nothing to do with compilation. In compilation, in your program, you tell how the memory is allocated. When compilation is done, at runtime, the memory allocation happens. Not at compile time.
Not assigning the stack.
It's a statement that runs at runtime. I'll give you an example for it in a second. Are we okay? We understand the syntax, right?
Ish.
So how do we do memory allocation and what we should do not to have any problem? Using an uninitialized pointer. If you create a pointer and start using it, you get segmentation fault. Because it's pointing, as you see, somewhere outside of the, God knows where, there's some value in it, right? Next thing, you set it to null, good for you. You keep the size somewhere, good for you, but you forget to allocate and you start using it. That's null pointer assignment. You create the variable, you hold the size, you stay within, perfect. If you go out, which means if the size is 7, mdata 7 is a failure. Remember, when you have 7, it's 0 to 6. Remember that. The size, if you get to the size, too late, it will crash. It's always one less than size, always less than size. The valid value for a memory is less than size, not the size
Do you mind
itself.
going back 2 slides, just so we don't have to, I'm sorry.
Pardon me?
Do you mind going back 2 slides?
The slides are online. You can just access them. The slides are on the repository. Okay. If you are already pointing to somewhere without removing that memory, you make that one point to a new memory, that's memory leak. There is no way to get that memory back because you lost its address. It will stay in your computer forever. What is the meaning of forever? Until you reboot it. It will always, when you are using Visual Studio, it will not, because it creates a virtual memory and all the allocations happen in there in the test environment. But if you take Visual Studio out and you run your program, then that's real memory leak. Okay, so don't worry when you are testing your program in Visual Studio or Xcode. That creates a virtual environment. There is no problem with that. But when you are actually running your program without Visual Studio, then that's memory leak. Have you ever had your, like at home, and suddenly your router doesn't work? You call Rogers and say, unplug the modem, wait for 15 seconds and put it back in? It means the program have memory leak. The router keeps running, garbage in memory, memory gets full, router doesn't work anymore. You remove it, you put it back in, and then they give you a new firmware, hopefully fixing all the memory leaks. Okay, so that's that. Correct state of unused pointer is always null and the size set to 0. You always keep track of what the size is. Correct state of dynamic memory allocation is to allocate exactly how much you want and you stay within the range that you are. And after you are done, you delete exactly how you allocate. You see I have a square bracket after delete. When you allocate an array, you have to delete like an array. If you only allocate one integer, if you say integer pointer A is equal to new int, that's it. Not an array, one integer. Then when you're deleting, you don't put the square bracket. It means there is only one thing I'm deleting. When you are allocating an array, you have to delete like an array. And when you delete it, you have to make sure you set the size back to 0 to have everything in sync. That's why dynamic memory allocation is so tricky. That brings nightmare for students. You make one boo-boo and tracing it is very difficult because there is no syntax error. You have to walk through every single step of the logic and see where you are actually making that mistake. You'll see it soon. If you incorrectly delete the memory, if you don't put the square bracket and delete it, because you are saying it was individual, it only deletes the very first element of the array, not the rest. Again, you're going to have memory leak. When you reuse the pointer, always make sure they are actually not being used. So checking to see if it's not equal null and taking care of it is a good idea. So if it's not null, save the data, okay? But you can always, if you don't care what's in it, you can always delete. Delete is null pointer proof, which means if you delete a null pointer, it doesn't care. There is no error with it, okay? But if you delete a pointer that has some garbage in it, then it's going to crash. So if you follow all the steps as I told you obsessively and always keep unused pointers null, you will never have problem. Because you delete it, it's null, nothing happens. If you forget setting it to null and you delete it, it tries to delete some memory that doesn't belong to it, therefore your program crashes. Okay? Reuse memory with new size, and so if you actually have a new size that you're setting, always set the new size to whatever it's supposed to be. Always stay within the limit of the size that you're in, and you're good to go. Are we okay with this? All right? All right. And we are done. So that was dynamic memory allocation syntax. Let's now actually do it. If I told you, yes. Yeah, I'm surprised actually. I'm going to have to push it right now and see what the heck is going on. Yeah, it's, let me actually, you're actually right. Let me just double check right now, since you said that. I'm going to go to Documents, Seneca, OOP244 NAA Nodes. I just want to test whatever we had today. So I'm going to say add all.
Yeah,
19th.
is this working?
It's interesting. It says success. It is committing somewhere. See, can you?
Yes, now.
They're all there?
Yes.
All,
September 19.
does it have 16, 9, and 2,
Yes,
too?
yes.
Huh.
I think you didn't send it out.
I don't know, because once somebody said and I kept doing it. I don't know. Anyways, we are good now. Okay, so I'll tell you what dynamic memory allocation is. I'm going to tell you like this, okay? It's very simple application I'm going to ask you to write, and you will not be able to write it without dynamic memory allocation. If I told you, write a program that receives few integers from entry and prints them in reverse order. This program is impossible to write because you don't know how many integers. You would say, okay, I will put 100. I would say, what if the person enters 101? You say, I'll put 1,000,000. I would say, what if the person puts 1,000,001? Anything you put, you don't know how many they are. So the safest way is to actually ask the user, hey, how many integers you're entering? User says 32. Then you can actually allocate 32 on the fly while your program is running. And that's dynamic memory allocation. So we're going to just write that right now. Okay? So what I want to do is to, very simple thing, I want to write a program that receives series of number and prints them in reverse order. Very simple. Okay? So the first thing I need to do is to say, I need to know what is the size, or size. How many do I have? And I need to know the numbers, right? So that's nums. Okay? So this is going to be dynamic and this is going to be the size of the array. Okay? Now, what's my mistake here? I did not initialize my pointer. Remember, obsessively. So the easiest way to set something to null or default is to put something like that in front of it. You do that, that's new C++. It's a universal way of setting something to its default. Or to learn actually what we are doing, I'm going to put over here is equal to null PTR. And I'm going to set the size to 0. Now I'm going to say, please enter the number of integers. I'm not doing any foolproofing, any error handling of any kind. We assume that user is sane, is not going to do cuckoo stuff, which is absolutely impossible. The fault of the system is that the user is not crazy cuckoo person who's doing crazy stuff. That's the default of a programmer, okay? That's when you're that's the default. Even if you are the person who's doing it afterwards. So you have to always consider that way. But for now, because we don't know how to do those stuff, I'm just going to assume that the user is sane. And then in here, I'm going to say cin size. So I'm getting the size, right? Now I have the size. What do? I'm going to create the array. So I'm going to say nums is equal to new int size. So at this moment, during runtime, during execution, the array will be created. Okay? So now I have the array. Now that I have the array, I can say for integer I set to 0 and I less than size and I plus plus. I can prompt, so I'm going to say, in here I'm going to say please see out. Please enter integers. Okay? Now I'm going to start putting the prompt. So this is going to be integer number, whatever it is. So I don't think I need that. Only comma will be, this is going to be fine. Okay. So now that I have it, I'm going to say cin into nums I, as if it's an array. Not as if, it is an array, but it's just a dynamic one. So it's going to actually get exactly how many arrays I have. Then what do I need to do? I'm going to say over here, cout. Here are the numbers in reverse order. So I'll go for integer I set to size -1, I plus I greater than or equal to 0, and I minus minus. So I'm going to say if I is not equal to size -1, then cout a comma. Now I'm going to say cout nums I. Right? I think it's right. Maybe not. We'll find out. Okay? All right? Yes?
What is the use of I plus 0 in the first for loop?
It shows the row. So if it's 32, you know which one you're entering.
No, but plus 0, why?
Oh, because I'm an idiot. It's +1. That's a boo-boo. Okay? It's +1, not 0. Okay? It's just typo. Are we good? So if I run the program, did I do anything wrong? Thank you. I have memory leak now. I have memory leak now. But it's okay. It's in Visual Studio. So enter number of integers. I'm going to say 3. Enter 3 integers. 1. I'm going to put over here 100, and 200, and 300. So the program runs and actually prints everything. And it doesn't give you anything, as if everything's good. You run this on matrix, you're not going to be able to pass. Because over there we measure the size of the memory before and after. If it's less, we say you had memory leak, fix it. Okay? So you got to be careful. Okay? Windows is very forgiving. Okay? Very forgiving. So now to actually make it right, I'm going to do this. Delete nums. Now that's correct. So usually when I'm programming, go ahead.
No, I got it.
You got okay. It's almost too late.
I'm pretty
Yeah, so as I was mentioning before, got distracted. What do I want to say? Yeah, when I actually write the code, it's my habit. If I know I'm going to delete at the end of the scope, when I do the int, I immediately write the delete, and then I fill in the middle, not to make sure I'm not going to forget. Now, just for the sake of syntax and learning how things work, I am going to even make this integer size dynamic, which is a stupid thing to do, because integer is integer. If I make it a pointer, I'm wasting space because I have a pointer and an integer, okay? But I'm going to do it anyway so you see how single values are allocated. So now I can actually do over here, write integer pointer size. This one I'm going to, whoa! I hate this automatic stuff that they do in Visual Studio. I don't know. Anyway, so line number 4 and 5 are identical. Their size becomes null for both of them. Null pointer for both of them. And in here I'm going to say is same as okay, so now that I have this, I have to say cin in target of size. And with target of size, please enter target of size. So everything becomes target of size because it's a pointer, right? Target of size, target of size. But at the end, I am going to say delete size. Are we okay?
No,
Why?
sorry. I think I missed that.
Miss what? Oh, I didn't actually created a new one. So in here before, so let's actually do this. I'm not going to allocate memory for size and run it and see what happens. Yes?
Do you need square bracket delete size?
No, it's a single entity.
Okay. Oh, yes.
How you create it, that's how you delete it.
Okay.
Okay? Now I'm going to see, as you see, I haven't done any dynamic memory allocation for size, right? So if I run the program, this is what's going to happen. 100, and I hit enter, poof, crashed, okay? Usually it's supposed to give me a message, but it didn't, it just crashed. And did it give me any message telling so?
No, it doesn't now.
I don't know. Well, usually it does, but anyways.
The updated version.
Yeah, but the good thing is that it actually tells you something like this. Hey, dereferencing null pointer size. You see that? So now if I actually write it properly, which is size is equal to new int, now we'll be good. Now it actually will be okay. So if I do it like this, I'm not going to say 100. I'm going to say, I don't know, 5. Okay, so 10, 20. Oh, there you go. Anyways, too quickly. Sorry. One more time. Control F5. Three. And there you go. Okay?
I don't understand size.
So, pardon me?
What is size equals new int?
For demonstration.
Numbers equals new int size is setting the array to the size, but how are you setting size?
Okay. Okay. Line number 4, it used to be a size, not a pointer.
Yes.
It was just a size variable.
Pointer now.
Now it's a pointer. It means I want to show you how to allocate individual stuff, not always arrays.
Yes, yes.
So size is a pointer. When I say new int, it means that size is now pointing to a pointer.
Oh, yeah, because it's not it doesn't mean the array size. That's
Okay? So just, yes.
So this was just for demonstration.
Just for demonstration. It's the most stupid thing you could do because size, integer is 4 bytes. A pointer is 8 bytes actually. So I'm losing memory by doing this. But for the other one, no. This is a beautiful thing to do because if you put 100 integers just in case and user only wants to do 10, then you are losing 90 most of the time. For the array, it's perfect because it really matches to the size that you have. But that doesn't make sense, okay? So let's do it like this. I'm going to change this, Control H, to size PTR, just to make sure we understand that, hey, this is not a pointer. This is not a size. It's a pointer to size. I'm going to say points to the size of the array. Now it makes more sense. Okay, so that's a pointer pointing to the size of the array. Are we good? That, ladies and gentlemen, is dynamic memory allocation. And it opens a humongous amount of possibilities. So what I can do over here is this. Take a look, take a look, take a look, take a look. Now I can say I'm going to say DMA. So let's say I want to efficiently get someone's name. So I want to have a function called character pointer get. Shoot, you don't know that yet. Well, I'll give you the example for it anyways. Get name, okay? So get name of mine is supposed to receive someone's name, but exactly the size I want. I don't want it to be, I don't want to have 50 characters in. So what do? I create a function called getName. I'm going to show you one of the methods of, what is a method? We had an example for it. Oh, what is a method?
A function in an object?
The function inside an object, right? Yeah. Cout is an object. It has functions inside. I'll give you, you'll see an example for it now. So I'm going to have, so let me just get rid of all this. So now in here, I'm going to create character pointer get name. So in here, I'm going to say cout, please enter your name. Now in here, I'm going to create, oh, that's get name, not get name, okay? So because it's a function, in here, what is the biggest size of name that you can think of? Biggest size?
200.
Seriously, you have 100. I'm going to go 100, okay? 100, okay? So I'm going to say over character temp 100. Why it's temporary? Because it's created in getName. When getName is done, that's going to get destroyed, right? It's a temporary thing. So I need string header file because I want to check the size. So I'm going to go string. And because of that, I have to add a define statement over here that I always forget what it is. It is define, I think CRT secure.
CRT secure no one.
CRD secure
No
no warnings. Is this the one?
Yes.
Okay, thank you. So now in here I'm going to say cin dot get line. Get line gets even spaces and stops at new line. So I'm going to say get line, and I'm going to put over here temp, and I'm going to say up to 100 characters. It already knows that 100 holds the null termination, so we are good. It goes up to 99. With this, I can actually enter spaces in it too. Okay? If you don't do that, space is a delimiter. You only can go up to a space. So I'll get that one. Now I'm going to say integer len is equal to str len of temp. So I have what is the length, right? Actually, let's not do that. I'm going to do this. I'm going to say character name is equal to new character str len of temp plus 1. So what do? Oh, character pointer name. So what is this thing doing? It says create an array of character to the length of temp plus 1. So this is exact match to the name they entered. Now that it's done, I'm going to go str copy into name the temp. And I'm going to say return name. What happens over here? It gets a temporary thing, right? And after it returns a temporary thing, what happens is that what does it do? So it says, please enter your name, and it gets the temporary thing. It allocates, puts the address in name, right? Copies everything into name, returns the address out. So the address will be returned with this. When this is done, temp will die and name will die. But who cares? The address is out. The target is out. The pointer is dead. So all I need to do in my main is to do this. Character name, pointer name, and in here I'm going to say name is equal to get name. Oh, that's too big. See out. Hello. I'm going to tell you why I type when you see I'm making the image. How, so in here I'm going to say, how are you? Okay, something like that. And then I'm going to say delete name. Because get name allocated it, and this was. So I have to make sure that in the documentation of name, what do? I go 1, 2, poof. It comes out like this. So what do? I'm going to say dynamically gets a name from console and returns it. Okay? It returns dynamic C string. So when user goes over here and wants to use it, it says dynamically gets name from console and returns it. It's a dynamic. So I will know I have to delete it. Okay? You have to have a proper documentation right beside the prototype of every single thing that you have, so people will know what it is.
Is there a command to delete everything?
Pardon me?
Is there a command that deletes every single
No, there is no such thing. It's C++, everything's manual. Okay? So now in here it's going to say enter your name. Now I'm going to say Fardad Soleimanlu, and I hit enter. It says that when it's done, and it exactly gets the size that I want. It's a beautiful thing. You good? So if I ask you to get 10 names and print them in reverse order, what kind of array you need to create to hold the names in it? Array of pointers. Array of pointers. We did that last time. So if I want to, it's 25. It's finished. It ends at 130 or 125? 25. So as an exercise, you're going to go home and you're going to write a program that receives 10 names. Okay? Oh, if you do this, like, it will be amazing. Go write a program that receives 10 names, sorts them alphabetically, and prints them. No. Yeah, 10 names. 10 names. Receives 10 names. Each name must be dynamic, not the array pointer. You don't know how to do that yet. I wanted to say unknown number of names. That's way too rich for your blood. For now, let's just go with 10 names, but each name is dynamically allocated, okay? So this is an uneven two-dimensional array, actually. But anyways, so do it and sort it alphabetically and print it. See how it works. That's a good question for a test. Yes? Give me a second. I have to finish. Are we good? Are we good?
Yeah.
All right.
We use a two-dimensional. We can generally use two-dimensional arrays, right?
No. It is an array of pointers. It's an uneven two-dimensional array. A two-dimensional array has specific width. This one doesn't have specific width. The first array is 10. The second one is 15. The third one is 2. The fourth one is 90.
I see what you're saying.
Okay.